Welcome! We now have a sequence of 3 lectures which are going to cover some features of object orientation which are often regarded as extremely important, but actually are perhaps in many ways less important than the features you've already seen of defining classes and objects of classes which communicate by sending messages among them. However, these features, inheritance and interfaces, are extremely useful in organising object-oriented systems code, so you do need to know about them. But just a word of caution, don't feel that you have to use every feature that you're going to learn in the next 3 lectures in every program you write. You might not need them. Use them when they're useful to you. Okay, I mentioned UML before, and this is the point where you actually get UML introduced briefly. UML, the Unified Modelling Language, is a language for specifying and visualizing object-oriented systems, and in particular a UML class diagram at its most basic level specifies a class name, its instance variables, its methods, and so on. You saw an example of this before, I think. So here we have a class called UGStudent with 4 instance variables, which are all private. That's the minus sign in front of them: matricno, name, age, and mailbox, and 3 instance methods: take, exam, graduate, and party. In this particular case, we aren't showing the types of either instance variables or instance methods. They will be present in the model, but they may or may not be suppressed from the diagram. That's a matter of convenience. A lot of what we're going to talk about in the next 3 lectures is classes that have stuff in common. So suppose we have 2 related classes because we want to have 2 related kinds of objects in our system. And one class, representing one kind of objects, is called UGStudent, representing the undergraduate student objects, and the other is PGStudent, representing postgraduate student objects. And these are very similar, as you can see. They have all the same attributes. The only difference is that the PG student has an additional method, tutor, because postgraduate students are allowed to act as tutors. So there are 2 things going on here. You might say, there's lots of duplication between these 2 classes, so wouldn't it be nice to be able to save the effort of writing that code twice? But more importantly, there may be many clients out there that should be able to work with both, and we don't want to duplicate the code of the clients, and that's actually much more important. How can we eliminate the duplication in both of those things? That's the job of inheritance. So an inheritance hierarchy allows you to abstract out common stuff. So what we say is, UGStudent and PGStudent are both kinds of student, and the only difference is that a PG student adds an extra method, tutor. And that's what this diagram indicates. The arrow with an open triangular head indicates generalization in a UML class diagram. This says UGStudent is a kind of student and PGStudent is a kind of student. Every UG student is a student. Every PG student is a student. Student is the superclass. UG student and PG student are subclasses. So a subclass inherits the members of a superclass, and a subclass is a specialization of a superclass. The superclass is a generalization of the subclass. You'll find there's lots of different terminologies here, and they all mean more or less the same, so we're just trying to introduce all the words you're going to come across at this point. Strictly speaking, a subclass doesn't inherit all the members of a superclass. We're going to say more about that in a moment. But first of all, let's have a look at the standard test that you can employ when you're thinking about classes that model domain concepts of your system, to work out whether it's sensible to allow X to be a subclass of Y. And that's the ISA test. So what you want to say is it the case that every instance of class X is an instance of class Y? Notice the way I said that. I don't really quite like the rather abbreviated wording of that middle bullet point there. The point is that an instance of class X should be an instance of class Y, or to put it another way, an instance of class X should have all the properties, and perhaps more, that an instance of class Y has. So you can take any undergraduate student and you can say every undergraduate student is a student. Okay. Now, in a real live lecture, we would at this point take a poll of the room with each of these examples. So I think instead, I'm just going to go through them one at a time. I'm going to ask you to pause before I give you the answer to each one, just to check that you've thought about it before I give you the answer. But I'm just going to go straight through. Okay? So now might be a good point to pause if you want to think about all of them before I talk about it. Okay. Now, okay, 1. Is kitchen a subclass of room? Yes, because every kitchen is a room. A kitchen is a kind of room. 2. Is room a subclass of house? No, because a room is not a kind of house. It's not the case that every room is a house. Rather, a room is a part of a house. That's an important relationship, but it's a different kind of relationship. 3. Is a violinist a subclass of musician? Is violinist a subclass of musician? Yes, because every violinist is a musician. At least, unless we're going to start being rude about particular violinists. 4. Sink subclass of kitchen? No. A sink might be contained in a kitchen or found in a kitchen. There might well be a relationship there. But it's not the case that a sink is a kind of kitchen. 5. Musician subclass of person? Yes, every musician is a person. 6. Lady Gaga subclass of singer? This is an interesting one. The answer is no, because Lady Gaga is actually an instance of singer. It's not the case that Lady Gaga is realistically a class at all, because Lady Gaga is a single instance, not a collection of instances. Okay. 7. Student subclass of musician? No, some students might be musicians, but it's not the case that every student is a musician. Okay, hope you've got that. Now, here we have again a slightly wrong statement that subclass inherits all the members, instance variables and methods of the superclass. I think we're going to correct that in a moment. In Java, we write that by saying that a subclass extends the superclass. Yes, here we go, finally. In fact, a subclass inherits all the public and protected members, that's instance variables and methods, of the superclass. It does not inherit the private ones. This turns out to be very convenient. But what is this protected thing? Well, protected there is actually here precisely to allow you a way to do something which is not quite private and not quite public, but is a very useful thing in between for contexts of inheritance. The issue is this. Suppose we have a class student with a private string name, and then we have a subclass of that, an extending class, PG student, which tries to use that attribute name. This won't work, because name is private. It's only accessible within the code of the student class itself. It's not accessible within the code of PG student. So name is not visible in the PG student subclass, so that won't work. Protected allows us to do it. So protected says that generally, it's not public, generally speaking other classes can't access name, but any subclass code of student can access name, and so then this code will compile and work. So in summary, here now we have all 4 access modifiers. We talked before about public and private, and we mentioned default, and we said don't use it. And now we also know protected. Okay, so protected is like public, except that it's not global. Okay, so you can access it from the class, from the package, from the subclass. So a subclass inherits all the public and protected members of a superclass. And a subclass can add new members of its own. Of course, you saw that. That's where we came in. The PG student can also tutor. Now, when you inherit something, normally you inherit it unchanged, and so it is here by default. When you inherit a method from a superclass, it's just like as though you had that method in your own implementation. It's just that, in fact, you didn't write it yourself, you've just inherited it. However, it's possible for a subclass to override the inherited method. In other words, to provide new behaviour for an object of the subclass to execute on receipt of a message which would already have been understood by an object of the superclass. Let's see an example. So here we have an example of a doctor class, and the doctor can treat patient. Any object of class doctor understands a treat patient message. And we have two subclasses, a surgeon and a family doctor. Don't take this too seriously, especially not if you have doctors in the family. Anyway, a surgeon can also treat a patient in a different way. That's why we repeat the method name in the subclass rectangle down there, and can additionally make incisions. And a family doctor inherits the treat patient, because one always inherits the public methods of one's superclass, and also creates a new give advice method. Let's look at this in Java. So perhaps the base class doctor, when treating a patient, does something rather general, like perhaps performing a checkup. A family doctor extends the doctor class not by overriding a method. It doesn't try to redefine that treating method, but it adds a new method. It adds this give advice method, tells you to wrap up warmly in this case. And notice, of course, that just as every public class must always appear in its own file in Java, so it is here. So the family doctor class, which is public and extends doctor, will appear in its own new file, familydoctor.java. Now let's look at the surgeon class. Now this one not only adds a new method, make incisions, which does whatever it does, but it also redefines the treat patient method. So in this case we're going to say, it's going to do some other stuff, perform surgery, it says here. We haven't specified what the code for performing surgery is, but suppose there's some Java code for performing surgery there. And one of the things it can do is it can call the superclass version of the same method. It can go super.treatPatient, as well as whatever else it's going to do, and it can do that wherever in the method it likes to do it. That's often convenient. So what about method overriding? What's going on? How do you override a method? So if you want to write an overriding method in a subclass, you have to have exactly the same signature, which is to say the name and the parameters with their types, as the method that you're overriding. We'll talk a bit about return type later. And the implementation in the subclass replaces the implementation in the superclass. So if you create a plain old doctor object and then you send it the treat patient method, the implementation that will be used is of course the one in the doctor class. If you create a new surgeon object and then you send it the treat patient message, then it's going to use the implementation in the surgeon class, the more specific one, the one that was designed for objects of this specific subclass. Let's see some examples.